Assalamualikum OyaRahmatullahe OyaBarakatuhu. Innal hamdanillah wassalatu wassalamu ala rasulillah. Amma ba'd. Bismillahirrahmanirrahim. This is Muhammad Kamrul Hussain, Department of Business Administration, Metropolitan University, Sylhet. Welcome to my virtual classroom, MKA Classroom. Now let's start today's video tutorial. Today we will talk about another different things that semi-annual and other compounding periods. Generally, we are compounding for annual or discounting for annual period. Annual compounding or annual discounting, the process of determining the future value or present value of a cash flow or series of cash flow when interest is paid once per year. Once per year. Whenever interest is paid once per year or discounting is once per year, then we are calling it annual compounding or annual discounting. So, for annual compounding, we are using formula FV equal to PV into 1 plus R power n. In the same way, annual discounting, we use PV equal to FV divided by 1 plus R power n. So, in the same way, for the discounting, annual discounting, we are using PV equal to FV 1 plus R power n. In the same way, for the compounding, we are using FV equal to PV into 1 plus R power n. So, that is our annual compounding and annual discounting. But now come to this point, that is our discussion is now starting. More than annually compounding and or more than annually discounting, more than once per year. Till we are talking about in previous sections, we are talking about the annual compounding or annual discounting. But there has another things which we will try to discuss, that is more than one period in a year, more than one compounding per year or per period, or more than one. That is, here has once per year, it is twice per year, thrice per year, fourice per year, or 5 times per year, or 6 times per year. So, that is more than frequently in a year. So, as like semi-annual compounding. whenever twice per year. The process of determining the future value or present value of cash flows or series of cash flows when interest is paid twice per year. When interest is paid twice per year, that means 2 times in a year. Here is once in a year, here 2 times in a year, that is called semi-annual compounding. Then we will see in here semi-annual. 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 Semi-annual, that means 2 times in a year. 2 times in a year. Semi-annual, 2 times in a year. Compounding or discounting, 2 times in a year. Whenever you are talking about quarterly, whenever we talking about quarterly, that means 4 times in a year. Quarterly, 4 times in a year. Monthly, 12 times in a year. 12 times in a year. Weekly, 52 times in a year. Daily, 365 times in a year. Weekly 52 times and daily 365 times in a year. Now, that is the questions arise. What will happen? Such type of things is arise. Semi-annually, quarterly, monthly, weekly, etc., etc. What will happen if this problem is arise? So, that is nothing a problem. Here m r divided by m and n into m. Then formula for such type of problems where more than one compounding or discounting, Fv equal to Pv into 1 plus r divided by m and n into m. That is for formula for more than one compounding in a year. Suppose 2 years and compounding semi-annually, then n should be 2. M should be 2 for semi-annually. M should be 2. M should be 2. M should be 2 for semi-annually compounding. M should be 4 quarterly compounding or discounting. M should be 12 if it is monthly compounding or discounting. M should be 52 it is weekly compounding or discounting. M should be 365 if it is compounding daily basis. So, it is clear that nothing will be changed, only M should be changed and others formulas are equal. FV equal to PV into 1 plus R divided by M into N into M. So, if it is semi-annual, then this should be 2. If it is quarterly, this should be 4. If it is monthly, this should be 12. If it is weekly, M should be 52 and daily should be 65. In the same way, for the present value, find out the present value. FV divided by 1 plus R divided by M into M. Nothing in this situations. So, PV equal to FV divided by 1 plus R divided by M and N into M, power N into M. That is our formula for finding present value or discounting formula, and this is the compounding formula, discount formula. Whenever more than compounding periods, others more than compounding periods, semi-annual, quarterly, monthly, weekly, daily, etc., etc. So, if we solve an example, then it will clear to us. So, here is an example. Suppose you have 1000 taka. Suppose you have 1000 taka in your hand that you want to invest today. How much would you have in 10 years if you put your money in a savings account that pays 10% compounded annually? How much would you have if your bank pays 10% compounded quarterly? That is our problem. So, that is easy problem. Here I say you have 1000 taka today and you deposit it to your savings account that will pay you 10% interest. What will happen to your amount after 10 years? N equal to 10 years and R equal to 10%. So, it is very easy, and present value equal to 1000. So, now we can see to solve our whiteboard, and here we can try to see solve our problem. In here we will solve future value equal to present value 1 plus R power n. Here I said first portion is annually compounding. So, 1000 divided by 1 plus 0.1 power 10. So, what will have to result? 1000 into 1.1 power 10. 2593.74. So, our result is 2593.74 74. And now another portion of our result of our problem is that how much would you have if the bank pays 10% compounded quarterly, 10% compounded quarterly. We know the formula AV equal to PV 1 plus R divided by M N into M. Quarterly means M equal to 4. So, here we have 1001 plus our interest rate is 0.10 divided by 4, 10 into 4. So, if we solve in our calculator, then it will have 0.10 divided by 4 plus 1 plus answer power 40 into 1000. 2068.660 2685 2685.06 2685.06. So, that is all our answer. Whenever banks provide interest quarterly, then the amount should be greater. So, you have to remember that more compounding in a year, more amount, more compounding in a year, it should generate more amount. So, now we will talk about effective annual rate. So, in this situation they create a problem, that means actual interest rate, effective annual interest rate, effective annual rate. Effective annual rate, the annual rate of interest actually being earned as opposed to the quoted rate considering the compounding of interest. So, here has the term effective annual rate, effective annual rate, the annual rate of interest that is actually earned as opposed to quoted rate considering the compounding of interest. So, in the previous example we have seen that our interest rate is 10%, our interest rate is 10%, but whenever we compounded it annually, then our result is 2593.74 taka, but whenever we compounded quarterly, same interest rate, but whenever we are doing the compounded quarterly, amount is greater than that, 2685.06 taka. That means it is more than 10% we have thought. So, that is actually the effective interest rate or effective annual rate. So, the effective annual rate EAR equal to 1 plus R divided by M power M minus 1. That is the formula for effective annual rate or effective rate. Effective annual rate or effective rate, that means which actually earned by this problem, which actually earned. So, in the previous examples we have seen that 10% interest rate compounded quarterly. So, our actual interest rate is 10%. So, here we have seen that 1 plus our interest rate is 10% and we are compounding by 4 power 4 minus 1, because it is compounded quarterly, So, actual interest rate is 0.1 divided by 4 plus 1 power 4 minus 1. That here has shown 0.10381. That means 10.38%. 10.38%. If we compound it, frequently in a year, then actually that is greater than that annual rate. So, suppose in the previous examples we have seen that when interest rate is 10% per year, our amount is this amount, but whenever same things compounded quarterly, that is greater than our annual amount. So, it shows that actually they earn more than 10%. So, that we can solve that problem is by the effective annual rate, EAR, effective annual rate, that is formula 1 plus R divided by M power M minus 1. So, when the annual rate was or simple rate was 10%, 1 plus 0.10, 0.10, or you can do this for no problem, divided by 4 power 4 minus 1, and it shows 10.38%. That is our effective annual rate. Effective annual rate. So, here as an example we will try to solve. Here as an example that we will try to solve, and I think that is the last example in this chapter. Suppose you are considering depositing 400 in one of two banks. Bank A offers to pay you 12% interest compounded monthly, whereas Bank B offers to pay you 12.5% compounded annually. Which bank offers the better effective rate? Which bank offers the better effective rate? So, it is clear that suppose you are considering your investment. Suppose you are considering your investment 4,000 in the two banks. One bank provide you 12% compounded monthly, and another bank offers you 12.5% compounded annually. So, here is compounded annually. So, it is a need not to calculate effective annual rate, because it is if you calculate this effective annual rates of bank B, it shows 12.5% for bank B. So, bank B, and now you have to calculate effective annual rate for A. So, our formula 1 plus R divided by M power M minus 1. So, in this problem we will see, here we will see 12% compounded monthly. So, 1 plus 0.12 divided by 12 power 12 minus 1. Then what will happen? Can you see? Yes, what will happen? Then we press in calculator, 0.12 divided by 12 plus 1 power 12 minus 1, that shows 0.1268 2. That means 12.68%. 12.68%. So, bank A will provide you 12.68% interest, whereas bank B will provide you 12.5% interest. So, now what is your decision should be? Which bank offers the better effective rate? Obviously, bank A offers better effective annual rate. Bank A offers better effective annual rate. So, you can invest your fund in bank A rather than bank B. So, understand? Can you make understand? So, bank A provides 12.68% and bank B provide 12.5%. So, A is obviously provide you more interest. So, you can deposit your fund in bank A. We are talking about compounding and discounting more than one period per year. We are talking about these matters. Here we will try to include continuous compounding. Continuous compounding, that means compounding of interest of an infinite number of times per year, at intervals of microseconds. So continuous compounding involves a nanosecond, every nanosecond. So in previously we have talked about semi-annually, quarterly, monthly, weekly or daily basis compounding, but there has another type of compounding that contains nanosecond compounding. That means continuous compounding, microsecond or millisecond or nanosecond compounding at the smallest period of time. So compounding of interest an infinite number of times per year at intervals of nanoseconds, milliseconds or microseconds. So the formula for finding continuous compounding, the formula for finding this continuous compounding is that future value equal to present value into exponential function power r into n. Here e, a small letter e, that is actually called exponential function. So if you have a scientific calculator, then you can have this button, that is a small e, not actually e, that is exponential, that is the Greek symbol about to e, not actually e, that is exponential functions. And if you do not have the scientific calculator, then you can write down or memorize the value of exponential, that is 2.7183. 2.7183. Maximum scientific, general scientific calculator has the exponential as a sign of e power x. So you can have this type of symbol in your calculator, e power x or exponential power x. So you can use that button to find out this type of future value problem. So here has x, you can write down the rate of interest into number of period, r into n. R means rate of interest and n means number of period. So that is the continuous compounding. And lastly, in the more than frequent once a year, we have learned that n should be multiplied by frequent in a year. That means period should be multiplied by period should be multiplied by m, that means frequent per year, and rate of interest, that is R, will be divided by m. R will be divided by m. That means frequent per year, rate of interest should be divided by m. Then all the problems can be easily solved by you. All the problems then you can solve if you multiply your frequent per year into n. At the same time, you have to divide it by your rate of interest by the frequent per year. Then all the problems then you can easily solve. And we have learned the tabular method as like future value equal to PV into FVIF RN. So whenever we are talking about the more than frequent per year, here also should be divided by m, and here also multiplied by m to solve the tabular method. To solve the tabular method, fin table method, fin table method. And in the same way, present value equal to future value into PVIF RN. We know the formula very well, but whenever we are talking about more frequent than in a year, then that should be divided by m and n should be multiplied by m. Then you have to find out the value from this table, then multiply with the future value or present value. In this way, we can solve about all kinds of time value of money problems. This all about today. Stay home, stay safe, try to maintain a safe social distance, try to wash your hands frequently in a day. Subhanaka Allahumma wa bihamdika ashhadu an la ilaha illa anta astaghfiruka wa atubu ilaika. Assalamualaikum warahmatullahi wabarakatuhu.